Hey guys, very good evening everyone. And hey guys, very good evening and welcome to another session of domain analytics, which we have been doing from the past few days. Talking about the domain analytics, we have been specifically talking about sports analytics in this session. And this training, these sessions are being conducted by 360DigiTMG. So till now we have understood about the sports analytics, what it is, what traits do you need to become a sport analyst? What are the benefits that you can reap by this particular domain? What are the things? What are the tasks that you needed to do? We also tried to do the EDA on a data set, open source data set, of course. We also did pre-processing. Yesterday, we discussed about how to do your k-means clustering for a particular data set pertaining to our sports analytics tool. Today, we will be discussing about k-nearest neighbor, how to perform that for a data set pertaining to our sports analytics. Okay. Today's agenda is going to be, we will try to understand what is KNN, what is K value in KNN, what are the step-by-step process of how to compute your k-nearest neighbor, what are the pros and cons and significance of a k-nearest neighbor, and along that, of course, we will be also discussing about a use case. So when I say KNN, the k-nearest neighbor algorithm is also known as a KNN. This is a non-parametric supervised learning classifier, which uses proximity to make classification or predictions about the grouping of an individual data. The k-nearest neighbor algorithm is simple, supervised machine learning algorithm, which can be used to solve both your classification as well as your regression problem. Remember, when we talk about machine learning, we have unsupervised learning and we have supervised learning. So KNN belongs to your supervised learning. And we can use it to solve our classification and regression problems. Talking about KNN, it is regarded as one of the most simplest algorithms because it is easy to implement and understand. But though it is very easy to implement and understand, but it is having some flaws also. It has a major drawback of becoming significantly slow as the size of the data in use keeps on growing. That is the drawback of the KNN. When we talk about KNN, we have to determine the K value also. K value indicates the count of the nearest neighbors. So we have to compute distances between the test points and the trained label points. Okay. And updating distance matrix with every iteration is computationally very expensive. And that is why your KNN is also called as a lazy learning algorithm. K value, as we know, indicates the count of your nearest neighbors. So, say in KNN, if you are finding your K values, that is not easy. A small value of K means that noise will have higher influence on what? On the result. And a large value, if I say we have, a small value, then it will be too noisy. That is it. And when we have, say large value, then it will make the things computationally expensive. Yeah. So what happens, say if your k is equal to 1 in your k array, what happens is that in KNN, an object is classified by the plurality vote of its neighbors, with the object assigned to the class most common among its k nearest neighbor. K is a positive integer, that means it will be typically small. If k is equal to 1, then the object is simply assigned to the class of that single nearest neighbor. And say if you have the k value as 3, then what? Then the labels, if we have k is equal to 3, then what? The labels of the 3 closest classes are checked and the most common, that is occurring at least twice, the label is assigned, and so on for the larger. So whenever we talk about k values in KNN, we have to ensure that every time your k value is an odd number. Suppose these are various data and there is a new data occurring. Then what will you do? You will find the distance of this data point to all other data points and choose the nearest one. Say this was the nearest one and you assign this to this. But what if your k value is 2? There comes a situation of confusion. That is why we always choose our k value to be odd. Right? That is the thumb rule that you should remember. So there is one more thing. People ask this question that, when you are dealing with the k nearest neighbor, what will happen when you increase the k? Will the bias will be increasing or not? The bias will be 0 when your k is equal to 1. When it comes to the new data, say in testing set, it has higher chances to have an error, which will cause what? If you have error, then it will be causing high variance. So when we increase your k value, the training error will also increase. Means your bias will be also increased. But the test error may decrease at the same time. That is, your variance will be decreasing. Right? Then comes the point that what is the step-by-step process on how to compute your k nearest neighbor. So first you determine your k, that is number of your nearest neighbor. Then you calculate the distance between query instance and all the training samples. And how do we calculate the distance, guys? We have Euclidean distance. Yeah. We have, say, Manhattan distance. And we have Mahalanobis distance. Based on this, you can find out the distance. Sort the distance and determine nearest neighbor based on your kth minimum distance. Gather the category of your output for the nearest neighbor and use simple majority of the category of your nearest neighbor as the prediction value of your query instance. This is a step-by-step process. that we need to follow to compute our k nearest neighbor. Talking about the pros and cons of KN. What are the plus points when we talk about KN? Obviously, we know that it is a very simple algorithm that is very easy to understand. It is used for the non-linear data. The versatile algorithm used for both classification as well as regression. In the first slide, we discussed about it. Besides this, it is also giving high accuracy. But there are more good algorithms in your supervised models when we compare them with your K. The algorithm doesn't demand, talking about this KNN, it doesn't demand to build a model, tune several model parameters, or make additional assumptions. That is the pros of your KNN. Talking about what are the cons, what are the drawbacks of your KNN. The requirement of a high storage, we know that, computational burden. Why high storage? Because your data size keeps on increasing and increasing. Hence, giving a computational burden. Hence, there's a requirement of your higher storage. Right? Also, prediction rate is slow. Lazy algorithm. It stores all your training data. And the algorithm gets slower when the number of examples or predictors or independent variable increases. When we talk about KNN, the KNN algorithm, if we talk about the usage, say particularly, then the KNN algorithm can compete with the most accurate models because obviously it makes highly accurate predictions. Therefore, you can use the KNN algorithm for applications. Talking about the usage, for applications that require high accuracy. In that kind of applications, we can use a K. So the application that require high accuracy, but they do not require a human readable model. The quality of the prediction depends upon your distance measure. Right? And I wanted to share something very important with you people. It was regarding your implementation part. Let me just quickly figure that out. Yeah. Few of the key takeaway points when we talk about your K-nearest neighbor. The algorithms learning in your KNN, firstly, it is instance-based learning. What it means? It means that here we do not learn the weights from training data to predict the output, as in like, we do in the model-based algorithms. But here, what do we do is we use your entire training instance to predict the output for your unseen data. That is your instance-based learning. Second thing, obviously we talked about it, it is a lazy learning. The model is not learned over here. Using your training data prior, right? We do in different models. First, we train the data, giving them the training data set. Then we have the testing data set. But when we talk about your KNN, model is not learned over here using your training data prior. And the learning process is postponed to a time when prediction is requested on new instance. So when a new instance occurs, that is where your learning process starts. So it is called as a lazy. Third thing, it is non-parametric. Which means in KNN, there is no defined, or rather I should say there is no predefined. No predefined form of what? Of the mapping function. Right? Okay. Besides this, what are the required data preparation that we need to do? Required data preparation. First thing, we need to do the data scaling. To locate the data point in multi-dimensional feature space, it will be very helpful if all the features are in same scale. Suppose you are having a data set, we having various variables, columns over here. Say this is 1000, 100, this is say 1000, this is say 100,000. It is not properly scaled over here. So what will happen when you will perform your analysis on this kind of data? Your accuracy will be getting hampered. Hence, you need to do the data scaling. Hence, normalization or standardization of your data will help. Second thing, dimensionality reduction. That is why, even in the real time, even you are doing supervised learning, in most of the instances, first you have to perform unsupervised, and then you need to work on your supervised learning, say on any data set. Most of the instances we need to do that. Dimensionality reduction. KNN may not work well if there are too many features. Hence, dimensionality reduction techniques like feature selection, that is nothing but your PCA, principal component analysis, can be implemented. So what will happen? Say you are having x1, x2, x3, x4, 4 variables over here. When you apply the PCA, you will get 4 principal components. Right? So how is the dimensionality reducing? We are getting means all the information from these 4 data points or 4 columns in this row are taken and computed over here. Say here we got 90% of the information. Your PC2 will capture another 5%. This will capture another, say, 4%, and this will capture 1%. Take the two, drop the rest. Why? Because it is holding maximum number of the information, 95% of the information. Now that is your call as a data scientist, whether you want to go with 100% data or you're just okay with the 95% data. Dimensionality reduction. Third thing is you're missing value treatment. Say if out of few features, one feature data is missing for a particular example in your say training set, then we cannot locate or calculate the distance for that data point. Therefore, deleting that row or imputation is required. Missing value. Right? Third thing, how do we implement your KNN in Python? Implementation of your k nearest neighbor algorithm using your Python scikit library. There are few, okay. If we talk about, machine learning, for a fact, we know we use scikit library for machine learning. So the first step is you get and prepare data. Second thing that you need to do is you need to find the value of it. We can choose, error curves, and k value will be optimal, variance. The bias error is chosen as your k value for prediction purposes, various things. Third thing you need to do is predict. Right? These are the steps that is required when we talk about our Python implementation. Significance of your KNN. Specifically, the KNN algorithm works in the way by finding a distance between the query and all examples. That is nothing but your variables of your data. Then selecting particular number of k values, say k nearest to the query, and then it decides the most frequent label if using for your classification based problem, or the average of the label if we are using for the regression based problem. Therefore, the algorithm usually depends upon the number of k values, such that the value of k means bigger the value of k increases the confidence in the prediction. The decisions may also be skewed if k is having a very large value. Measures of asymmetry. Yeah, making sense? Nice. Okay. So now let me quickly take you to my Jupyter notebook, and here I have used a data set, open source data set for my KNN to find to perform your k nearest neighbor algorithm. So I've imported my required libraries: pandas for data manipulation, numpy for numerical calculation, I have imported matplotlib. I have imported my seaborn graphical representation, advanced graphical representation. I've imported my data set over here. And after importing the data set, I wanted to observe the top 5. Just okay. Your top 5 inputs. So I've said data.head, and it is giving me these things. Again, this data set is particularly for our, the sports analytics. So I've taken Neo Sports Prediction Master data set. I wanted to know the last 5 observations, so I've given data.tail. I wanted to find out the number of variables and the observations. That is nothing, but I wanted to find out your number of rows and columns. So I said data.shape. I got 9,840 rows and 20 columns. For a fact, we know over here that the first part represents your rows, second part represents your columns. Data.shape, I have 9,840 rows and 20 columns. I also wanted to know the data types. I gave my data set name over here and I said .d types. So it is giving me my data types. I have these particular columns. Game is your integer, date is your object, game location, type ID is integer, so on and so forth. And when I said data.describe, it is providing me my mean, standard deviation, minima, maxima, 25th, 50th, and 75th%. So here I'm performing my descriptive statistics. Then after analyzing all these things, then I started venturing into my data preprocessing. So the first thing that we discussed that we need to be very careful with our missing values when we talk about KNN or when we perform KNN. Because what happens in the KNN, try to understand the chronology over here. Various data points and a new data point occurs over here. You try to find the distance with each and every data point. If there is a missing value, this calculation is getting hampered, or there will be a sense of ambiguity over it. So you need to get rid of that. In order to get rid of that, you need to find out whether there are any missing values or not. So I took my data set name, I'm saying data.isNA.sum, and here I'm getting no missing values. I also checked for my duplicated data over here, I am having 0. What I did over here is, when I was taking my date column, okay, it is not showing over, yeah. When I was taking my date column over here, I wanted this to be converted into your date time format. So I said, from pandas to date time, take the date column that is into your dataset data. Whatever values you get over here after performing this particular function, store it in that same column in my dataset data. After doing this is what I got. Right? Now, I am trying to build my KNN classification over here. I am trying to consider before 1st of February 2022 as my training data. So I have said data, take data date should be less than 2nd of February 2018. I'm finding out the shape over here. I'm saying train dot height. Then I'm trying to, finalize my training data. Just a moment. Yeah, sorry, this is the testing data. So testing data, I have taken greater than 2080 February and 2nd of February 2018. Again, the shape I found out the head, so on and so on. I am choosing my win and date column from the columns, and I'm dropping that from my train data. Values which I get, I'm storing it into a variable called as x underscore train. Axis is equal to 1. Whenever we have axis is equal to 0 and axis is equal to 1. This denotes your rows. This denotes your column. I got the shape over here. I said, take this column win on your train, and whatever values you get, store it into a variable called as y underscore train over here. I tried to find out the shape, so I am having 8,476 rows over here. From my testing data, again, I wanted to drop your win and date. Axis was 1, means these are the columns, obviously, so the axis will be 1. I dropped that. I found out the shape, and I am saying the shape means whatever you have over here, take it as a test data, store it into a y underscore test, found out the shape, this was the shape. I have imported, for a fact we know that, for the machine learning, we need to use your sklearn. From sklearn, I'm importing standard scalar as well. Python sklearn library, it offers us with standard scalar function. It is used to standardize the data values into a standard form. So we initially create a standard scalar function. Further, we use, see, this is the standard scalar function that we created. And then we use fit underscore transform along with the assigned object to transform the data and standardize it. Why do we need to standardize it? Again, the same thing that I told you. If we are having a data set which is having various data, say this is 100, this is 100,000, 1,000, this is 100,000, so on and so on. When you perform your analysis on this kind of data, this will be creating a lot of confusion or ambiguity, or there will be low accuracy, right? So we need to bring all this data into a standard scale. We need to do the scaling. Hence, I have imported a standard scalar from sklearn.preprocessing. I have made a function out of it. I am using that function by fit underscore transform on my training data and my testing data. So whatever values I am having over here, it is going to scale all these values. I am importing from sklearn neighbors. I am importing accuracy score. Sorry for that. So I am importing your neighbors. I am importing your accuracy score. I am importing your confusion matrix and classification book. When we talk about neighbors, say there's an algorithm that is used to solve the classification model problem. KNN or your, KNN, if I talk about KNN, then it basically creates an imaginary boundary to classify the data. When the new data point comes into it, the algorithm will try to predict that to your nearest neighbor or the nearest of the boundary line. That is your neighbor. When we talk about accuracy score in Python, accuracy can also be defined as the ratio of the number of, say, correctly classified cases to the total number of cases under evaluation. The best value of accuracy is 1 and the worst value is 0. Right? That is your accuracy score. Confusion matrix. I hope you people are aware of the confusion matrix. I have also used my confusion matrix over here. Confusion matrix, guys, is nothing but a table that is used in the classification problem to assess where errors in the model were made. The rows represent, so you will be having some matrix over here. The rows represents the actual classes the outcome should have been, while the columns represent the prediction that we have made. That is your confusion matrix. Classification report, you people are very much aware. So here I am taking my number of neighbors is equal to 30. I am using my k neighbors classifier. I am using neighbors. Whatever I am getting over here, I am storing it into an object called as a value. The values which I got over here, I am taking that, which is nothing but a model, and I want to run this algorithm. Whenever you say dot fit, your algorithm will start running. On what? Obviously on the training data set. Even before testing, I need to train. So I'm using that on my training data set. You will get the output as k neighbors classifier n underscore neighbors. For predicting the value, I am using this on my testing data over here. I'm trying to find out the accuracy over here on my testing as well as my prediction value. By using the accuracy score, I got the accuracy of 0.77, that is nothing but a 77%. I tried to calculate my confusion matrix over here on my testing data and predicted value. I got 467,210. These are your columns, these are your groups. I have taken my ACC is equal to null value for the range 3 to 100. I have said take all the neighbors, I is equal to all the neighbors, fit this model on my training data, use your KNN, means use this function to predict the values on your testing data, store it into predict underscore I. Whatever accuracy score you are getting on your testing data and predicted value, store it, keep on appending, means keep on adding on this null variable which we have created. I have also plotted the figure. Figure size is 10,6. You can give any parameters over here. Plot range was 3 to 100. 3 to 100. Accuracy versus k value was the title. On the X label, I have my k value, that is nothing but what we have defined over here, 30. On the Y label, we have the accuracy. So here, if you observe, where are we getting the maximum accuracy? Choose that point. as your optimum k value. Rather than running your, algorithm on various k values, choose that point where you are having your most accurate values or where you are getting a maximum accuracy, and say that my model will run only for that k value. And this is how we perform our KNF on our data set called as newsport. And this was the data set that I have used. Let me show you. Not this one. This was the data set that I have. People who have asked for the data set and the codes, I will be forwarding all your data sets and codes when we will be ending our sports analytics, the final day of that. I will be forwarding you people on the mail all the use cases, data set, and codes that I have used for. I'll be forwarding all of that to you, right? So guys, this is where I am going to stop the session for today. Hope you guys must have had a very enlightening session. So again, thank you so much guys for joining the session. Happy learning everyone, and we'll be meeting again on Monday. Tomorrow we won't be having the session. On Sunday also we won't be having the session. We'll be connecting again on Monday, and I have other various interesting topics to be covered. Thank you so much guys for joining.